So let's just see how we can implement the queue using the linked list. Now in a queue we have two ends. We have the front end and the rear end. Now we can insert new items from the rear end, and we can delete existing items from the front end. So that means if we wanted to insert a new items, we can do this from the rear end. Now if we wanted to delete existing items from the queue, so we can perform the deletion from the front end. Now to implement the queue, either we can use one array. Now also we can implement that using one linked list. So the linked list consists of nodes, and each node has the data part and the link to the next node. So this way the linked list will contain multiple nodes. Now here in the linked list we can have multiple nodes, and all of the nodes will be connected using the link. So here also we're gonna have the front pointer, and also we're gonna have the rear pointer. Here also we can have the data inside the linked list. Now in case of array, the problem is that here the size is fixed. That means we cannot increase the size of the array. But in case of linked list, here we can dynamically allocate the memory. That means in case of linked list we can grow the size whenever required. So because of this, in case of linked list, we're gonna have no wastage of the memory, because whenever we require the memory we can simply allocate the memory. So which is not possible in case of array. So here we can have the wastage of memory. So let's just see how we can implement different operations of the queue using the linked list. So first of all, let's just see how we can implement the enqueue operation. Enqueue means adding elements to the queue. So initially, because our queue will be empty, so the front pointer and the rear pointer, both of these pointers will be pointing to null. So because our queue consists of multiple nodes, so first of all we have to define this single node. So here is the definition of the single node. So we are using the structure. Now in a single node we're gonna have the data. So here we're gonna have the data, and also we're gonna have pointer to the next node. So this is the link or pointer to the next node. So this is the definition of a single node. So here is our definition of a single queue. So we're gonna use the structure to define the queue. Now in a queue we're gonna have the front and the rear pointer. So this is our front and the rear pointer. So here is the function to perform the enqueue operation. So here in the function we're gonna pass the queue and also the value that we wanted to add or insert into our queue. Now here first of all we're gonna create one new node. So we're gonna use the malloc and we're gonna allocate the memory. And after that we're gonna check if the memory allocation is successful or not. So if not new node, that means when the memory allocation fails, so then we're gonna print memory allocation failed and we're gonna return. Otherwise, if the memory allocation is successful, so that means we have allocated memory for a new node. Now in that new node we're gonna put the value that we have received in the parameter. So that means here we're gonna have the value, and also we are setting the next pointer to null. So that means the next pointer will be pointing to null. Now after that we're gonna check if the queue rear, so that means if the rear pointer, if that is pointing to null, that means our queue is empty. So when the queue is already empty, then we're gonna update both the front pointer and the rear pointer, and both of them should point to this new node. So that means both of these pointer will be pointing to this new node, and then we can return. So this is the case when the queue is already empty. Now suppose we previously had some values in the queue. So suppose previously we had two nodes in the queue with the values 1 and 2, and we have link between these two nodes, and the last pointer is pointing to null. Now in that case, if we wanted to insert this new node into that existing queue, so in that case we have to update the rear pointer. So we're gonna update the rear next pointer to point to this new node. So that means this rear next pointer should point to this new node, and then we're gonna update the rear to point to this newly created node. That means we're gonna update this rear pointer to point to this new node. So that means this node will be inserted right here in the end position, and we're gonna have the link to this last node. So you can see this new node is successfully inserted at the rear position of the queue, and this is how we can perform the Enqueue operation. So let's now see how we can perform the Dequeue operation. So Dequeue means deleting a node from the front end of the queue. So that means we have to delete this node. So here is the function to perform the deletion. So as a parameter we're gonna pass the queue. Now inside the function, first of all we're gonna check if the front is null or not. So when the front is pointing to null, so when this front pointer is pointing to null, that means our queue is empty. So when the queue is empty, then we're gonna print queue is empty, and then we're gonna return. So otherwise, if we have nodes in the queue, in that case, first of all we're gonna create one temporary pointer. So that means we're gonna create one temporary pointer which will point to this front node, and after that we're gonna get the data from the node. So here we're getting the data from that node, and then we're gonna shift our front pointer to point to the next node. So the front pointer will be shifted to point to this next node so that we can delete this node. Now after shifting the front pointer, if we see that the front pointer is pointing to null, so after shifting the front pointer, if we see that the front is now pointing to null, so that means we had only one node in the queue. So if we delete that, our queue will be empty. So in that case, we also have to update the rear pointer. So the rear pointer should also point to null. So we're gonna update the rear pointer. So the rear pointer also should point to null. After that, we're just gonna free the memory that is allocated by this temporary pointer. So that means we are gonna simply delete this node, and then we're gonna return the data, and this way the node from the front end of the queue will be deleted. And next we have the pick operation. So the pick operation means returning the value from the front of the queue. So here in the function, this will take the queue as a parameter. Now in the function, first of all we're gonna check if the queue is empty or not. So if the front pointer is pointing to null, that means the queue is already empty. So in that case, we can print queue is empty, and then we can return. So otherwise we can just simply return the value from the front pointer. So that means this value from the front pointer will be returned without removing that node. And similarly we have the isEmpty operation. So with this we can check if the queue is empty or not. So here in the function we can perform the simple check. So if the front pointer is pointing to null, that means the queue is empty. So this is the way we can implement all of these different queue operations using the linked list. So hope you understand the concept. See you in the next one. Take care.